Hi all, today we are going to discuss about the factors affecting the corona loss. So there are different factors which will affect the corona loss. Let us see what we have discussed in our previous class. We have seen in our previous class the power loss P can be written as 241 into 10 to the power of minus 5 into F plus 25 divided by delta into square root of small r divided by small d into Vp minus Vc whole square. This will be in kilowatt per phase per kilometer. This is for the case of the peaks formula which we have studied in the last class. And similarly, the value of the voltage. So let us take this as equation number 1. So we have also read the value of the voltage Vc is the critical disruptive voltage which is given by R into G naught into M into delta into ln of d by R. This is in kV. Let us take it as equation number 2. And we have also seen as per the second formula, that means this power can be calculated if the ratio of Vp by Vc is less than 1.8. So in that case we have seen the Peterson formula will hold good, and we have seen that value will be 1.11066 into 10 to the power of minus 6 into F into Vp square divided by ln of d by R whole square multiplied by F, kilowatt per phase per kilometer. This is what we have seen, and we have also discussed that this F is a function of the ratio of Vp divided by Vc, where the value of Vp is the value of the phase voltage, per phase value of the voltage, and the delta is air density factor which is given by 3.92 into B. B is the barometric pressure of HT divided by 273 plus T. So let us take this as equation number 4 and this as equation number 3. So these are the factors affecting. So let us see one by one factors which are related to this, how they are going to affect. So first I am starting with the effect of frequency. Effect of frequency. So you can see either from the equation number 2 or equation number 1 or equation number 3. In both the cases we are seeing the power loss Pc is directly proportional to the frequency. That means as the frequency is increasing, the effect will be more. If the frequency is less, the effect will be less. So this is what is the first observation. Then the second observation is what is the effect of system voltage. The effect of system voltage. So again from this formula, because we can tell that the system voltage whatever is Vp, it is proportional to Vp square, and as per the first formula also it is Vp minus Vc whole square. So we can tell that it is proportional to the value of Vp minus Vc whole square roughly. So we know that as the value of the voltage is increased, voltage of the system is increased, so due to this the potential gradient at the surface will increase. So as the potential gradient will increase, the power loss will increase. So as for the first formula, we can tell the value of the power loss will be Vp minus Vc whole square. The power loss is proportional to Vp minus Vc whole square. So if the value of Vp is very near to Vc, that means Vp is very near to Vc, then in that case the Pc, the power loss will be less. But as the value of the Vp is increasing, so Vp minus Vc will increase drastically, and you are taking square of that, so automatically the loss increases drastically. That means above the critical disruptive voltage, as the value of Vp is increasing, the power loss becomes exponentially increasing at a very faster rate, as square times it will go on increasing. That is what we have to observe from here. Now coming to the third effect, the effect of density of air. So air density correction factor, we have seen this air density delta is equal to 3.92 into B divided by 273 plus T. This is what we have seen. So we can tell that the barometric pressure will decide the value of the delta. So because of this delta, what happens? That is depending, Vp is depending on the value of the delta. So delta is going to affect there, and even the power loss also, in the power loss equation we can see the delta is coming in the denominator. The delta is coming in the denominator. So it is greatly going to affect the value of the corona loss. So as the value of the air density is increasing, so automatically the value of the corona loss also will goes on increasing. It will go on decreasing. It is inversely proportional. Or we can tell that as the value of this delta is increasing, then the value of the corona loss will increase. Or otherwise we can tell in terms of the barometric pressure, as the barometric pressure is increasing, then the corona loss decreases. But if you are taking for example the flat area as well as the hilly areas, in the hilly areas the value of the barometric pressure is less compared to that of the flat areas. Flat areas the pressure will be more. That's why we can tell in the hilly areas, as the value of the B is very less, so the value of delta will be less. So automatically here the power loss will be more in the hilly areas compared to the flat areas. So this is what is observation effect of density of the air. So let us see, there is one more effect of the air that is going to affect, that is effect of conductivity of air. Conductivity of air. So before proceeding, I want to tell you I am providing the complete handwritten material in the description of this video. There is a Google Drive link there, you can download the complete material from there. Here I am only trying to teach you the concept, because remaining written material whatever required for the exams you can please download from there, because I am writing on a glass screen, because what handwriting will not come properly, that's why I am providing the complete handwritten material from there. Okay, let us proceed. So the effect of conductivity of the air, because the conductivity of the air, so conductivity of the air depends on how many number of ions per unit volume are there in the air, and what is the size and the charge per ion. How many number of ions are there per unit volume, and what is the size of each ion, and what is the charge per each ion. Because as the size of the ion increases or the weight increases, the conductivity decreases. As the charge per ion is increasing, conductivity will increase, and as the number of ions per unit volume is increasing, in that case also the conductivity of air will increase. So it is practically observed that if you are taking at a sea level, so it is observed that the value of this charges per cubic centimeter will be 650 positive value per cubic centimeter, and there will be 550 negative charges will be available at sea level. So let us assume I am moving a little farther ahead. So if you go to around 2000 meters, so if you go to the 2000 meters above the mean sea level, so this value becomes 1050 positive carriers and 850 negative carriers. Let us assume I have further gone a little high, so let us go up to 5000 meters. That means you are going towards the, from the mean sea level, that means going towards the hill areas. It is observed this charges will further increase. It will be 2350 positive and 2000 negative carriers. So you can see here, as you are going for the higher level, automatically the number of carriers are increased. When the number of carriers are increased, the conductivity increases. So automatically the power loss due to corona increases, because the carriers are more, so more corona loss happens in this case. And not only with this, whenever the thunderstorms comes, so this increases the number of ions in your atmosphere. The number of ions will increase. Where the number of ions are increased, automatically the corona loss will increase. So this is the effect of the conductivity of the air. Now coming to the fifth effect, the effect of rain, dust, etc. So during the rain, when the rain is coming, we know that automatically the moisture in the atmosphere increases. So, or we can tell that the number of carriers increases. When the number of carriers are increases, automatically the PC will increase. So similar is the case, as the volume of the dust is accumulated, so automatically your surface becomes irregular. So when the surface becomes irregular, what will happen? Because we know if the surface is irregular, then corona loss will be more than the case of a smooth conductor that is already seen. So automatically the value of PC will goes on increasing. And one more factor is there, the effect of the rain and dust. It depends on the size of the conductor also. Let us assume if the size of the conductor is big, so in that even if some dust particle comes or some rain particle condense on this, so this creates the more edges, so automatically the effect of corona loss will be more. Let us assume that if the conductor diameter is very small, so in that case whatever the rainwater comes, the rain particles that falls on this will be of very big size, because of that the irregularity, effect of irregularity will be very less in the case of small conductors in the case when compared to that of bigger size conductors. So we can tell that if the conductor size is big, so the effect of the rain and dust particles will be more as compared to the conductor which is of smaller size. This is what I mean to tell. So next, let us see what will be the effect of radius of the conductor. Effect of radius of conductor. So the radius of conductor, two parameters will be there from the equation number 1. So we can see that the PC is proportional to square root of R into Vp minus Vc whole square, and we know the value of Vc is proportional to the radius, is proportional to the value of the radius. Here you can see here radius term is also coming. So minus is coming. So if Vc is increased, automatically PC is decreased. But here square root of R is also coming. So therefore, as the value of the radius is increased, the square root of R is increased, but the increase in the value of Vc is dominating. Or we can tell the value of Vp minus Vc whole square, the decrement is far less when compared to rise in the due to the effect of the value of the radius. Or we can tell the total corona loss will decrease. So we can tell for different type of conductors for a given conductivity, when compared to the copper conductor, the ACSR conductor size will be bigger size when compared to copper conductor. Or we can tell the radius of the conductor will be more in ACSR conductor compared to the copper conductor. So we can tell that for a given conductivity or a given weight of the conductor, the ACSR conductor radius is more. So automatically the corona loss in the ACSR conductor will be less compared to the equivalent conductivity copper conductor, because copper conductor size will be small. So let us see what is the effect of conductor surface. So the surface of the conductor also decides how much is the value of the corona, how it is going to affect. So practically we always go for the ACSR conductors. ACSR conductors, we know the center strand will be there, around that the multiple strands are kept. So automatically the strands are there or the irregularity will be there. So let us assume when the line is designed, let us assume your irregularity of the conductor is like this when the line is designed. So what happens, because of this irregularities, because the corona loss will only concentrate on the wherever the peaks are there. So because of the corona loss, because whenever the corona loss comes, because of the corona loss it forms the ozone gas. So because of the ozone gas, the oxidation happens. Oxidation on the surface of conductor happens. Because of the surface of the conductor, because of the oxidation, the surface becomes more smooth. When the surface becomes more smooth, this conductor will become like a smooth conductor, and automatically the effect of the corona will decrease. So generally this process takes about 6 months. That means whenever a new line is erected, in the first 6 months the corona loss will goes on decreasing, and after 6 months, because it will become nearly flat because of the effect of the oxidation due to the ozone gas that is produced due to corona. So after that the corona loss will be nearly constant for remaining part of the life of the conductors. So getting it? So now coming to what is the effect of conductor heating by load current. So effect of conductor heating by load current. Generally, because of the load current, there will be I square R loss. Due to the I square R loss, always the conductor is heated. So the heat is increased. So this heat is not going to play any role in decreasing or increasing the effect of the corona loss. But let us assume on a rainy day when it is raining. So during raining, this heat doesn't have any effect. But once the rain stops, so at this condition the conductor will be wet. So because of this heat, this conductor will become dry at a faster rate. So because when the conductor is wet, the corona loss will be more. It is already known to us, because number of carriers will increase and it will attract more dust and dirt onto the surface of the conductor. But because of the heat that is produced, it will become dry at a very faster rate. Once it becomes dry, automatically the corona loss decreases. So what I mean to summarize from this is, under normal condition the heating of conductor doesn't have any effect, but during a rainy season, once the rain is over, the conductor dries at a faster rate. Due to that, the corona loss will decrease at a faster rate once the rain stops. So how to decrease the effect of the corona? So to decrease the effect of the corona, because we can see from the equations that if you are increasing the distance of separation between the conductors, so in that case the value of the PC will decrease. But if you want to increase the distance of separation between the conductors, automatically the length of cross arms increases. When the length of cross arm increases, then the tower strength required will increase. So this increases the cost drastically. So this is not feasible to do practically to increase the distance of separation between the conductor. So the better solution for decreasing the corona is go for the bundled conductors. So when you go for the bundled conductors can be stated that in that case the value of the GMR will increase, or this can be treated as the increase in the radius of the conductor. We know that when the radius of the conductor is decreased, automatically the corona loss get decreased. So this is the only solution that is allowed. So practically always your value of the per phase voltage will be equal to 1.1 times the critical disruptive voltage. So generally we don't maintain more factor of safety, because we know under normal operating conditions or the dry conditions the corona loss will be nearly absent, and corona loss will be severe only under foul or the bad weather conditions. Generally that foul or bad weather conditions happens for very few days or few months of the year, and during that time the power loss, it is observed that the amount of the money that is spent due to the power loss is far less than the extra money required if you want to increase the distance of separation between the conductors, because all the installation cost, the fixed cost will increase drastically. So that's why always practically the value of Vp is taken as 1.1 times of Vp under normal weather conditions, and corona is let to proceed under the foul weather conditions. So I hope the complete concept of the corona is completely clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.